are the things you have to think in order to be able to process the problem. So what makes the problem a little bit higher level now? Another random variable. So it is not very clear what that I is. I picks some number in this range randomly with that distribution. So this means that whenever this happens, you need to think about conditioning on I. Because if I is one specific value, let us say 1, 2, 5, etc., you can answer the question. But now the problem is that I is also not certain. I will pick up a number from this range. So this means that whenever this kind of thing happens, you remember it's better to condition on that I. Okay, and then of course, probably if you have read the text. So for example, can you tell me how can I make condition on this, because you can calculate expectation value using condition. So how can I calculate that? So it's like the total probability formula. Do you remember we had it before? So I can say that expectation value of xi, so it will be expectation value of xi if I is I multiplied by the probability of I to be I. Yes, and then I have to run I from on all possible values. What are the possible values for I 1 to n? Yeah, so let me write a little bit with a different color. Is that understandable? Yes, because if you have P, let me write something like this. Expectation value of a random variable. So in principle, what I'm telling you, you can write P of x if y is y, for example, and then you multiply by the probability of y is equal to y, and you add on all y's. Okay, so what I am using is this. Okay, this is correct? So let us start from the right-hand side of this expression. Let us refresh a little bit about the method. So if I want to prove that this is indeed the case, I want to start from the right-hand side and go back to the left-hand side. But I need a definition for this. So what is the definition of this thing here? I'm just doing it for the case of discrete, but for the case of continuous, it's very simple. So what is the definition? Do you remember? This is a sigma x, and then you have the joint probability distribution, say x on the condition y is that, and then you have x, and then you run it over x. So this is definition. Definition of this thing. Okay? And then how can I continue now? I will take this with me and put it here. Okay, so I'm just trying to motivate you that this is indeed correct. I have started from the right-hand side. For this one, I ask myself what this is in the first place. Then I remember that this is the definition of this expression. So I plug this back here to see what it is. So I have a sigma here. But this is not part of the solution. I don't think you need to justify this in the exam. You can just use it. Okay. So this sigma, and instead of this guy, I put that thing. So there's another sigma here, and then I have x, p, let's write p, small p here. Small p, x, y is y, and then x, and then I close it. This is this one, and then after that I have this one. So what can I write for this one? I can write little p, and I can write y and y here. This is this. Yes? Okay, but what can I do? I can combine the sums. Yes, and then x times this times that. Agree? Okay, but can you tell me what can I write for this combination? Do you remember this was probability, joint probability distribution of So if I multiply that expression there, what is left for me is just the joint probability distribution. So then it becomes equal to sigma y sigma x, and then I will have x. I will write something. If you have trouble, please let me know. If you have trouble here, so what I have done, instead of this guy totally, I have written this. Understandable? Yeah, please interrupt me if you don't understand. But now what I will do, I will interchange the sums. So it becomes sigma x first, sigma y second. I'm doing it in very detail because I want you to see it once and then you can continue yourself in similar problems. And then this x does not depend on this counter, so I can flip it out. So then it becomes sigma x, x, sigma y, t, x and y, summed over all y's. What is that? You have joint probability distributions summed over all y variables. So it becomes the marginal probability distribution, yes? So this becomes sigma x. I copy and paste x, but instead of this guy, I hope that you can see that I can write this. Yes? But what is this now? I hope that you can immediately see that this is but I don't think you really need to justify this here. Just ask loops, okay? So I can just immediately start that, and then I ask you to help me, okay? So, first of all, this is something strange. So what is the answer to this? Can you tell me?
1 over n.
Yes, because this is the probability that this random variable I takes I is within this range, and according to this probability distribution, this is indeed PII, and then this becomes 1 over. Yes? So, and then 1 over n, it does not depend on the counter, so I can pull it out. So then this expectation value becomes 1 over n sigma. I goes from 1 to n, and then I have e xi if I is the ith one. Yes? So this means calculate the expectation value of this random variable, but the index is no longer random. It has picked the specific value of it. Okay? So how can I calculate this? Okay, by the definition that I wrote here for you, yes? This is of this type, and its definition is here. Okay? So, but of course, instead of y, I have capital I. Instead of little I have little I. And I'm giving the role of capital X with this. So if I write that, what happens? So it becomes sigma. Instead of running over x's, I will run over i's, yes? So yes, the values of this, so let me see, how can I write it? If I want to calculate this one, then I have to write sigma. Be careful, xi is Poisson with parameter lambda I. Okay, so this means that f of xi calculated at some number, let us say k, let me write it with p, is equal to e to the power of minus lambda I, and then you have lambda I to the power of k divided by k factorial if k is 0, 1, 2, etc. So that is the translation of this. Okay, so I put that expression here, so I want to calculate this expectation value. So the values of xi are these numbers. So if you don't mind, let me write k, and I run it from 0 up to infinity. And instead of xi, I put the output of my random variable, which in this case is k, and then I multiply it by p of xi times k. That's it. And then I want to calculate this sigma. K goes from 0 to infinity, and then I have k. And then this one is exactly that expression. So let me put something here. You're not confused. Yes. Okay, our duty is to simplify this and calculate. So how should I do that? First of all, this is not a problem for me. Why? Because the counter of the sigma is k. There is no k dependence here, so I can pull it out. And the second thing, do you remember we had this yesterday? The first one is 0 because of this k here. So it starts from 1. Yes, so I can just write it as this. It becomes equal to e to the power of minus lambda I, and then I will start from 1 if someone asks you why, because the first term coincidentally is 0, so I thought I have to start from 1. And then in your head, you can write this as k times k minus 1 factorial, and then this k here will cancel that k totally. And then I will have lambda I to the power of k, and then I have divided by k minus 1 factorial. But the usual trick, you know how to do it. Yes, I want to start from 0. This becomes e to the power minus lambda I. Okay, I start from 0 again.
You need to change the k in the exponent.
What? Yes, I have to change, but not now. Yes. So if I'm just changing. Might be that is necessary. I'm not sure. But this, if I do that, then it becomes I have to add k here to compensate for this change. So this becomes lambda I to the power of k plus 1 divided by k factorial. Yes. This is very similar to the Taylor expansion of the exponential function, except that I have an extra lambda here, and that's not a big problem because I can pull that one single lambda out because that lambda does not depend on the counter. So it becomes e to the power of minus lambda I, and then sigma lambda I to the power of k divided by k factorial. K goes from 0 to infinity, and hopefully you can immediately recognize this is nothing except e to power lambda I. And e to power lambda I multiplied by e to power minus lambda I, they are cancelled, and what is left for me is just simply yes? Okay, so hopefully you are not confused. You remember that was the first question mark up there. I wrote it like this, and then I calculated this one. So this is what I want to calculate, and I calculated this one. It turns out to be lambda I. So this means that finally e of xi is equal to 1 over n sigma I goes from 1 to n, but lambda, and that is the answer even in the book. You're supposed to prove this. And then of course, because of simplicity of writing for the next problem, they have defined lambda bar to be 1 over n this. So in principle, what does it mean? It means that we were able to show that this is nothing except lambda bar. So that is interesting. So the expectation value of this random variable is the expectation value of the randoms. Yes? Which one? And this is the what we want to prove. The rest of it is the notation that the book has introduced to write it shortly. Okay. So they have said that okay, this is the answer. But they say that okay, because they want to answer the variance again, they have introduced this little piece of notation to make it simpler to write. Okay, any questions here? Okay, so hopefully you know the next one, I want to calculate the variance. But you remember the formula for the variance. What is that? The variance of this xi can be written as expectation value of xi squared here minus expectation value of xi totally squared. Yes? So this I don't have any problem. This is just simply lambda bar. We just calculate it. So I have to calculate this. But I hope that you see that the process is the same. Yes? Let us do it a little bit faster. So, do you remember where did I start from? But of course you have to use this, what is it called? Unconscious statistician thing or something like that. So if I want to calculate that, so I will go up there. So first of all I condition again. So I would write it exactly as the one there. So I would write from I equals to 1 to n, but then I would write e of xi squared on the condition that I is equal to I multiplied by the probability that I is equal to I. I'm using exactly that formula that I justified on these green lines. Okay? But again, you know that this one is what? 1 over n, so I can pull it out. Then sigma expectation value of xi squared, and then I have I is equal to I. For the same reason, this means that 1 over n sigma exi squared. Yes, okay. And now what do you think I will do? I have to calculate this one. So let's do that one. But in order to write, so I'm just following exactly the same thing. So I have xi squared is equal to. So where did I start for ei? Yeah, e. E of xi. I have to calculate, write something like this. What would be the difference for this case? Can you tell me? This is e of xi. I wrote it this way. Now using this unconscious statistician or something like that. What should I write for that one?
Replace the left-hand k with k squared.
K squared. Yes, that's it. So these are the values of this random variable. If the random variable x of I takes these values, the random variable xi squared will take squared values. And then you have to write this as sigma. K goes from 0 to infinity, k squared, and then I would write that. So becomes the probability of xi k. But then this is also just calculus course now. So we have to calculate series, yes? So this becomes k squared, and then again instead of this I would write minus lambda I. I have lambda I to power k divided by k factor. This becomes a little bit harder probably because of having k squared here. Again, do you agree that I can start from 1 because the first term is 0, but 1k simply cancel that one, 1k survives. Okay, that's the bad thing. So let me just do it patiently. So I go from 1 to infinity. So let me draw something to draw your attention to it. Okay? And then again, k factorial can be written as k times k minus 1 factorial, 1k simplified. By the way, I can pull this out again. So let me write it here. Okay, so this will be just simply k lambda I to power k divided by k minus 1 factorial. I don't know how much you are familiar with these problems from your one variable calculus. So how can I calculate this sum now? This is a problem here. But do you remember, have you seen the trick for these kind of calculations? No? The idea is to use derivative. Okay? So this means this is equal to e to power minus lambda I. Let me write something, and then when you learn that, you probably will be able to do it. I would write it like this, and can you help me now fill it up? I want you to write something here, so that after being, because you know that if the series converges, absolutely, which in this case it is, I can actually differentiate term by term. So all of those things you don't need probably to explain. But can you tell me what should I write here, so that after being differentiated with respect to lambda I gives me this? No, just, yes, it is integral, but just do it in your head. Because that's just a constant, and this is k lambda I to power k. So exactly like in high school, if you have 2x to power 2, if you have 3x to power 3. Yes, so what can I write? The integral. The integral will be 1 power I. So what happens here, it becomes, let me write it first, might be you will see what I mean. Oh, it's not working now. Yeah, because k plus 1 goes down, so okay, sorry. This is not working. Do you know what we should do? We have to change the limit first, because that was problematic. So let me change the limit now again, e to the power, but yeah, you have to do some trial and errors sometimes. So k goes from 0 to infinity, and then this becomes k plus 1, and then this becomes lambda I to power k plus 1 divided by k factorial. Yes? Can you see how this solved my problem if you have what I told you in mind? Before doing that, what I would write is to if I raise it to power 1 more,
it should be lambda to the power k plus 2, and then
2.
you should
Okay.
divide
If I want
by.
2, so I have to divide by 1 lambda I. Here you are right. So I am just in, but you will understand why I am doing what I am doing after it is done, and then you have to put this in your toolbox. Yes. Sometimes.
Shouldn't you just divide by a new exponent, k plus 2?
What? No, let me see, I'm confused a little bit, so let me see. I want to write a derivative so that it works. No, it should be k plus 1. No, okay, sorry. Yeah, you told me that. I'm so sorry. So this becomes e to the power of minus lambda I. Let me write d lambda I, of which one? Sigma k goes from 0 to infinity. And then I would write lambda I to the power of
K plus 2, right?
k plus 1. Just don't write, please. Let me see if it works. So if I do that, what will happen? K plus 1 goes down, and it becomes, okay, so, yes. What I will do, I will take 1 out first, and then, so there is another lambda I here, and then write this. Okay, are you with me now? You see, in principle, I will take this 1 lambda out, okay, in your head. And the power will be 1 less. And that one is this, the derivative of this one. So let me tell you in this way. Do the derivative in your head. What will happen? K plus 1 goes down, and then lambda I will be to power k. Do you agree? And of course the denominator is k factorial. But then this lambda I will be multiplied, and it will increase this power by 1. It is correct. Is that right? Yeah, it is. Are you confused or not? So do this derivative in your head, what will happen? K plus 1 goes down, which I need, good. K factorial survives, which I need, good. But the power will be what? 1 less. So it will be lambda I to power k. In anticipation of that, I have an extra lambda I here, which after being multiplied will give me this back. Is that okay or not? Yes or no? Say something.
Yes.
Okay, so now what happens? Again, I am in trouble. Because this is not something that I know. I have to pull one lambda I again out to make it exponential function. Yes? So this becomes e to power minus lambda I, and then I have lambda I here, then I have dd lambda I, then I pull one lambda I inside the derivative, and then I will have sigma lambda I to power k factorial, k goes from 0 to infinity. Okay, so let me clean everything not necessary here. So if I ask you, let me just one explanation. If I ask you what this is, k plus 1 goes down, correct? Lambda I to power k, which is bad because I want to have lambda I to power k plus 1. And then because of that, I put a lambda I here. But then the problem is that this sigma, I want to know what this is. I only know if they are the same. So this motivates me to put another lambda I out here, but because this is derivative with lambda I cannot move it out. I have to keep it there. Okay? And then if I ask you, do you know this? Hopefully your answer is yes. What is the answer to this? E to power lambda I. So then it becomes e to power minus lambda I times lambda I, dd lambda I, and then I have lambda I e to power lambda I. Please check my calculations. Are you okay? Now let us differentiate, but this differentiation is super simple. So it becomes, let me write lambda I here to make it more beautiful. And then the derivative of this one with respect to lambda I itself is 1 multiplied by the second function plus the first one multiplied by the derivative of the second one. Yeah, that is correct. Yeah, you have to do some trials and errors. But I want you to understand the idea. You have to engineer it to work it out. And then I hope that this becomes simple, because if I multiply this inside, this will cancel that one. It is 1. That is also 1. So I am left with lambda I multiplied by 1 plus lambda. Yeah, sorry for the mess. I didn't sleep very well. Okay. So then what happens here? I put it back in this equation. Yeah. So what is the final e to the power of xi squared? So we calculate that. But my goal is to calculate this. Do you remember? I want to calculate this. That was the reason I got interested in this expression. I went here. I calculated that one. I have the result. I put it back here in order to find this. Yes? So let me put some star here. And then now, using the star, what can I calculate? Expectation value of xi squared is calculated to be 1 over n sigma lambda I times 1 plus lambda I. I goes from 1 to n. Yes, do you agree? I use this star. But then let me open it up. It becomes 1 over n sigma lambda I plus lambda I squared, but I can break the sigma into 2 parts, decompose it. I goes from 1 to n plus 1 over sigma lambda I squared. I goes from 1 to n. Yes? So I multiply this in lambda I squared, decompose the sigma into 2 parts. But what was the name of this guy? It was lambda bar. So this becomes lambda bar plus 1 over. There is nothing you can do for this. And this is finally the answer to this one. But let me put double star here now. This formula. I want to calculate the variance. Variance of xi. So I am using double star here. Okay, so So the variance becomes what? This one calculated minus minus this one squared. So this is lambda bar squared. That is exactly what we want to prove according to the answer in the book, but in the book they have written this next to this. It's lambda bar minus lambda bar squared plus 1 over n sigma lambda I squared. Okay, sorry for that confusion. Any questions? The next problem, I'm not sure how to explain it, because the next problem is problem 6, next page. Yes. Let us keep it for the time being, because there is a rule that if I have some independent random variables that they are exponentially distributed, then there is a very simple way to show that the sum is a gamma distribution. Okay, but the best way to prove it, that's what I'm a little bit confused, is to use these moment generating functions. Then it becomes extremely simple to show them. I couldn't prove it in another way, but because I knew this, of course I was able to prove it using mathematical induction. That was a little bit of cheating because I already knew the answer, but that's the weakness of mathematical induction, yes. So let us keep it, and then of course I will try to come back to it, and I will ask, am I allowed to use this? Because then if you want to use these moment generating functions, it would be just one single one to prove that the sum is a gamma function. Okay, but if I have time, I will come back to it today and then discuss about how to solve it. But this is a very beautiful problem, by the way. I really enjoyed solving it. And that was the reason I couldn't sleep very well this night, because it was not that straightforward for me. Okay? Okay, so, but the next question, I would say that this is a very standardized question. It is question number 8. Is it on the same page or something like that? Question number 8, something like that. The same section, question number 8. So that's a very, I mean, I would say that this is a very good problem. So it is problem 8. On page, can you say what the page is the same? 108, thank you, and then this is the same. Now, this is a very standard, I think, calculation. So, they have given you the joint probability distribution of two random variables, which is C multiplied by x plus y, if 0 less than x less than y less than 1, and 0 otherwise. This was given in the problem. Let us do it case by case. Part A, they want you to find C. And the answers, that is very good. The answers are all provided here. Okay. Okay, so how can I calculate C? Very standard calculation. Can you tell me? Just want to refresh. Yeah, the integral over both range should be 1. Yes? So, but it is good to know this range, I mean the support. So if you draw the support, it always helps you. So if this is x, this is y. This is in the unit square here, but of course x should be less than y. So x and y are equal on this line. So if you want, I can draw dotted lines here. So this is the line y equals to x, and this point is 1. And this one. Okay, which part is acceptable? Upper triangle or lower one? Upper one, yes, because I am interested in those places where x is less than y. So this means this is my support. Yes? So I have to integrate, because other places except this region, this is vanishing. So the only thing that happens is just here. Okay, so I would integrate this over that domain. So if you don't mind, let me call this domain D. I need to calculate the double integral on domain D of this function. dx dy and equate it with 1. Okay, but if you don't mind, let me call this integral I. So let me call it, yes, j is better. So let me calculate j now. So how should I calculate? If I want to calculate the double integral of this region, it's a very simple problem. You have to decide about which one you want to give the role of independent variable to. So which one you want to give. In this way, I prefer to give y the role of independent variable. So I will write integral for dy first. But I have the option that I choose y, any number between 0 and 1. So I would run it from 0 to 1. And then I have the integral of my integrand. My integrand is up there, dy. Okay, but the logic is this. I told you in the first lesson, you remember, you choose one y here. For this particular y, you just do a cross-section, horizontal cross-section of your region and ask yourself, for this particular y, what is the lowest x and what is the highest x?
You have to
It's
dy.
This is dx. Yes? So can you tell me what are the limits now? For this particular y, the smallest x is the x coordinate of this point, and the biggest x is the x coordinate of that point. So the x coordinate of this point is clear. What is that? 0. But what is the x coordinate of this point? It is not a fixed number, it is y, yes, because x and y are the same, so I have to write up to y. C is a constant, I move it out, and this is a very simple integral to calculate, so it becomes integral from 0 to 1. I put dy on the other side. Yes, and I calculate this. Integral of x with respect to x is 1/2 x squared, plus integral of y with respect to x is nothing except yx, but I have to run it from 0 to 1. And then let us calculate this. This becomes c, integral from 0 to 1. If I replace x with y here and there, it becomes 1/2 y squared plus y squared. So it becomes 3/2 y squared dy. And then this becomes c over 2 y cubed from 0 to 1, which is c over. Yes? Please stop me if you don't understand something. So my calculation shows that j is equal to this. So j is equal to c over 2 based on my calculation, but j should be equal to 1 according to the definition of this function. So this means that c is. So that was very simple. The next one is also simple. We are supposed to calculate these two functions. So part B, we want to calculate f of xx, and we want to calculate f of y. Okay? And that's a good exercise to refresh your memory. So how can I start calculating this? Remember that from now on c is 2. So how should I calculate this? The definition. Yes, so the definition goes that integral, I have to integrate of the joint probability distribution on the other variable. If this is x, I have to integrate over y, and then in principle I have to write y from minus infinity to infinity, but of course you have to adjust it. But be careful, the logic is this: x is already fixed for this. So x is given. For that particular x, I am calculating this integral. But again, technically speaking, you have to define this everywhere on the real line. So, for example, if x is less than 0, less than or equal to 0, or x is greater than or equal to 1, I can calculate this immediately. What is the answer? 0. Because outside the domain, this is 0, so this is 0. So that is in principle necessary, right? And then this means that now I have to limit myself. So now I am choosing x somewhere between 0 and 1. I am choosing that particular x. Have in mind that x is fixed somewhere there. For that particular x, you are calculating this. So how should I calculate this then? So I have to write my integrand, which is c x plus y, and then I have to dy. But c is what? 2. Yes? Can you fill up the limits for me? For that particular x is chosen. If x is chosen between 0 and 1, let us pretend that this is our x. Okay? And then see that on that line, what are the limits for y? What are the limits for y? The lowest y value is here. The highest y value is up there. But the highest y value is 1, regardless of my choice of x. But the lowest value of y depends on my choice of x. What is that? X. Yes? So this is the logic. Okay? So then you continue the calculation. This is simple. So so let us do it in our head. So this becomes, your variable is y. So this becomes 2xy. The next one becomes y squared over 2. That 2 is cancelled. Then I have to run it from x to 1. Be careful, I have to replace for y, so it becomes 2x plus 1 minus 2x squared minus x squared. So this means that will be what? 1 plus 2x minus 3x squared. And of course, if you really want to write it, you have to write it this if x is between 0 and 1 and 0 outside. This is the first one. Okay? Now let us calculate the next one. So part C. Also no, that's the same part, but I want to do it, so let me do it a little bit quicker. So this becomes integral from minus infinity to infinity, and then I have f of x and y, xy, and I have to differentiate it over x. But again, if y is above 1 or below 0, I don't need even to calculate. So if y is less than or equal to 0 or y is greater than or equal to 1, f of y is indeed 0. So this is why I assume that y is somewhere between 0 and 1 and I want to calculate. When you say y is somewhere between 0 and 1, it means you fix it. When you fix it, for that fixed y, you want to calculate this integral. So the integral will be 2x plus y because that's the same function, but this time dx. Can you fill up these ones for me? What are they? For that y is fixed here. So the lowest value is 0, the highest value is x. So it becomes 0 to x. And then this is simple. So it becomes x squared and then plus xy. Then I have to run it from 0 to y. 0 to y. 0 to y, sorry. So then it becomes what? There's a 2 here. Yes? X squared over 2 cancelled, but this becomes yes, 2. There is a 2 here. And then this becomes what? 3y squared. Am I right? Y squared plus 2y squared, 3y squared. So yes. So f of y is equal to 3y squared, of course, if Is that okay? Okay, if you want to have a break, let us have it for 6 to 7 minutes right now and then come back and continue. Okay? Expectation value of x. That's very simple, I think. But this is a very good exercise, to be honest, to review things. So, e of x is equal to what? So do you remember, this is the problem, everything is on the board. So for calculating this, because this is a continuous random variable, what should I write? I would write integrals from minus infinity to infinity. And then f is, yes, I have to calculate this. But this is very simple. I don't even need to bother this because it was not 0 only here. So this means that I integrate from 0 to 1 x multiplied by that function. Yeah, don't underestimate the role of simple exercises. They are very, very important. Because it gives you the right tools actually, so to think. So then I multiply this, it becomes x, 2x squared minus 3x cubed. Yes? This becomes x squared over 2. This becomes 2/3 of x cubed minus 3/4 of x to power 4. But I have to run it from 0 to 1. So it becomes 1 over 2 plus 2 over 2 minus 2 over 4. Take the common denominator 6, 8, 9. What is that? 5. So E of x is the answer that it is given in the book. Yes. And then finally, this is a little bit nicer problem. Part, what was this part? This was part C. And then I have a part D. Okay, so part D, I want to calculate E x if y is equal to 1. Okay, so let me ask you one question. Let us say I write something here to be 5x. Do you really understand that this is a typo? Yes, because this should be a function of y. Okay. So, how should I calculate this now? I need the definition. Unfortunately, I erased that. Do you remember what was the definition of this guy? What should I calculate? Sigma, integral, and then the values of this random variable, but multiplied by what? Yes. Okay. On the whole range, but let us see what the range will be. So this means that in order to be able to answer this question, that is my duty now to calculate this. Okay. So how should I calculate this? Again, I have to use my definition. So what is the definition of this? This is fxy yes. And we have to be a little bit careful because everything we need we have. F x and y is given up there, c is 2, we calculated c there, and this one we just calculated it here. Okay, so again remember y is fixed. Okay, so y, where should y be? Outside of the domain, if possible. If y is outside that domain, then there is no chance. The expectation value will be 0. So it means that if you want to get some non-zero value, you have to limit yourself for that y between 0 and 1. So imagine that y is between 0 and 1. Otherwise, this will be 0. So then this becomes what? This becomes 3y squared. Yes. And then that one is already up there. It's 2 times x plus y in that domain. Because outside the domain, I have 0. So I plug everything here. Hopefully, now you know that. So let me write it here now. So what happens? This becomes integral. I have x multiplied by 2 times x plus y divided by 3y squared and dx. Okay, now can you tell me what is the range of this x? Y is already chosen somewhere there, so you need to find the range of x. So what will be the range of x? Y. Y is already chosen, so it should go from 0 to y. Yes? Y is already chosen, somewhere between 0 and 1. Exactly that horizontal line. Okay, so then what happens? I can pull this out because it is completely, it does not depend to my variable, and then I pull 2 out. Integral from 0 to y, and then I multiply my x in. So this becomes x squared plus xy dx. Then it becomes 2 over 3y squared multiplied by this one is x cubed over 3. The other one is 1/2 x squared, but y is a constant, and then I have to run it from 0 to. Am I going too fast or is it okay? Is the pace okay? Okay, because if it becomes very elementary, go a little bit faster because I'm sure that you can do it later if you don't understand it here. So if I put y, it becomes y cubed plus y cubed. So it becomes 1/3 of y cubed, half of y cubed. It becomes what? 5/6 y cubed. So am I right now? So this will be this 2 and this cancel 9, 5/9. What is the answer? Oh, I made a mistake. No, that's correct. That's the answer. So it was a very good exercise, I would say. It teaches you a lot. Can you see what the page is?
109.
Thank you. So so the problem 14, page 109 on the same questions. Okay, so that's a very, I remember I really liked solving it because I had a little bit confusion a little bit first. So I have two random variables, and then something is written is this, y on the condition that x is x is first success distribution x, and they have told you that f x is 3x squared if x is between 0. Okay, let us do it case by case. The first thing that I want to calculate is the expectation value of random variable y. Let me write everything here. I want to calculate expectation value of y. I want to calculate variance of y. I want to calculate covariance of x and y. And I want to also calculate p of y. It will be probably a long problem, but I think it's worth it because it teaches you a lot of things. Yes, try to be active and try to answer my question. I will give you a little bit of time to think.
Sorry, what is S in this?
Fs is first success distribution. You need to go back. Whenever you see this first success distribution, you remember that it means that you try just throw a coin. The first time it comes heads, for example. Okay. So if you refer to this, let me translate this for you. If that is something that you need to go and look into the table, I didn't even remember it myself. But now I think I remember. So this translation means, if you look back, this means that because this shows that if you go here, this is the discrete random variable. So this means that you have, let me show p, little p, y on the condition that x is equal to x is equal to, on y, because that would be a function of y, it becomes x times 1 minus x to the power of y minus 1 if y is 1, 2, 3, etc. This is something I didn't remember, but yesterday I did it, so I remember more or less. This you need to understand how to translate it from here to here. Because this x here is playing the role of the parameter. If you go there in the book, instead of x they have put p, okay, and instead of 1 minus x they have put q, and then they have written that p plus q is 1. So I just wrote it backwards. Okay, so that's the translation. This is very important because if you cannot translate it correctly, then even you cannot budge. You know? So e to the e of y. How should I start calculating this? Yes? Yes, so can you tell me what should I write? Exactly, we had it, but let me just read you this. This becomes sigma
then conditional probability
E of y
given x
multiplied by
E of x.
something like that. Yes? And then I should run x. X goes from where to where?
0 to infinity, but then it becomes 0 to 1.
What? Okay. So this is not correct. You know why? Because this one is continuous. So I have to write an integral. Okay, that's good to understand. Let me cross it over. And that's the same thing, but I have to write integral of e y x equals to x, and then I have to write f of x. So these are extremely important things, you know, because I am writing on x, and x is continuous variable. Then of course you know that outside this rel it is 0, so it is clear that I have to run it from 0. So there is no sigma. This is the continuous version for that. Okay, here of course I don't have any problems. I have this one. So this is just 3x squared. So then the problem is to calculate this one. Yes. So I want to calculate Ey if x is x. Okay, how can I calculate this one now? This time I am doing expectation of y variable, which is a discrete random variable. Yes. Yes. So what should I write here? Can you help me? You have to be comfortable with writing the correct formula, because if you don't do that part, then it will actually waste your time. Especially in the exam, it becomes extremely stressful. Yes.
Isn't it just like given? Because we said that it's from distribution.
No, that one is given. This one. But I am calculating expectation value. So what should I write here?
Sum
Over.
the index goes from 1 to infinity.
So I want to choose y. Not as, is it 0?
1.
No, 1. Yes.
Then I'm a bit unsure.
Y times probability y given
Y times probability of y, x is equal to x of what?
y.
Y. Yes? So you see, you have to be comfortable in writing the correct formulas, otherwise there is no hope to continue. Okay? But can I continue now? Yes. That one translated itself in this language. Yes. So I can put it there. So this becomes sigma y multiplied by what? X do you agree with me? Can you check that y starts from 1 or not? I hope that it starts
If
with
it
1.
starts from 0 again, the first term is gonna disappear.
Yes, so that's good. Yes, you don't need to worry. But I have to write it correctly, yes? I think y starts from. Okay, so the only thing that I have to do for the time being is to calculate this sum. And you have enough experience now. Okay, so let us do that. First, what do you do? Which term I can pull out? This is counted on y. So x can be pulled out. Can this term be pulled out? No, because it depends to y. It depends on y. So this becomes x sigma y 1 minus x y minus 1 y goes from 1 to infinity. Okay, I told you the method. So that is one tool in your toolbox, means brain, yes? So you have to remember this trick for calculating these kinds of sums. Can we engineer that so that I can calculate this sum? So if this y was not there, was it problematic or not?
Yeah.
No, if y is not there, no problem. If you have problem, even if y is not there, you have to review things. So if y is not there, what is the problem? Is the problem easy for you or not? The reason I'm asking these questions, that is what, because if that one is not simple for you, then how you have the chance to solve the harder one? Yes.
Is it a binomial theorem or is it
No,
differential?
binomial theorem will be horrible. Yes, because if I expand this, it will be something with y terms, and then I want to sum over y terms.
Is it
Yes, it-
differentiate?
No, but look at this. What is this? Come on. Yes? Geometric series, yes? It's geometric series. Why? Because if you put y equals to 1, it becomes 1. If I put y equals to 2, it becomes 1 minus x. The next one will be, say something please. The next one will be
1 minus x to the second
power. And the next one will be 1 minus x to the third power. So every time I am multiplying by 1 minus x. Yes? So I could solve the problem. The unfortunate thing, it is not that because of this existence of y. So you have to engineer them. And this is what I wanted to learn because I told you, you see, I was confused when I was solving this problem to correctly engineer that. So can you engineer that for me now? 3 minutes.
Which problem did you have?
That's a difference. You remember I was a little bit confused here to engineer it in the right way by derivatives. So that is why mathematical ideas, yes, I mean there are few brilliant mathematicians like Terence Tao, okay? But more working mathematicians just know these tools as plumbers know how to put the pipes. Okay, so these are the techniques. So you have to value it. If you don't value it, okay, why do you think that then in the exam every problem is a new problem for you? Yes? But when I was studying probability, writing this was new for me, and this was something I already know and I remember. So when I reach to here, I would say, I know the solution. But there is no moment for you, because every step will be a new obstacle. Of course, you will be disintegrated. Yes, or degenerated, depending what. But this is something, this is their mindset. And I would say that if especially you are a math major and you want to be a professional mathematician, this is, I think, I'm not sure this is the correct way of doing it, but I hope that you understand me. If this problem doesn't look similar, something familiar to you, how do you want to do it? But now everything, go back to your notes, if you have forgot. Please try to engineer this one for me.
I don't think this is what you're looking for, but I have a hard time explaining it. What you will have there is a bunch of partial sums. You have x minus 1 minus x to the 0th power once. You will have x minus
No,
1
y
minus
is
x
also
to the first power twice. You will have 1 minus x to the second power 3 times, and so on. So you can split it up into partial sums and then see if that's correct.
Oh, that is one way of engineering.
But I don't think that's what you're looking for this time.
No.
No.
I mean, not because I say no, I don't know how to engineer that in a correct way. Because these coefficients will increase as well. Then you want to split it into a lot of sums probably. Might be worse.
Sort of a triangulation of partial sums.
Yeah, might be. That's work. I haven't thought about that. But this is a very standard trick. The notion of what was the idea here, the main idea here I used. Can you say one word? Differentiation. Yeah, differentiation. But that is the same thing. Okay? So you learned a word today, differentiation. Yes? Differentiations for solving series. For finding series sum. Okay, can you engineer it now? I want to give you 4 minutes, you see.
So it should be x.
Oh, please engineer that, everyone. Let us give the chance to everyone. Write it down, please. Your experience. I hope that you agree with me. I want to put a dd y. dd x. What? No, because dy will be exponential differentiation. Yes? So what is the difference? Because you know that when I was teaching in high school, when I taught the students to do this derivative, they do like that. But when I wrote this, and I asked them to take the derivative, many people did this. Okay? But how do you teach a student that the difference? This is called what? A
Power.
power function. This is called an exponential function. What is the difference? This one, x is variable, c is constant. This one is the other way around. The formulas of differentiations are not the same. In this problem, so what is the correct one of doing it? Is this one. Okay? And then of course you can see that if I want to differentiate with respect to the top one, I have some ln to live with. I have already problems, so let us not make life harder. Okay? So I would write d dx, and then how can I write it here? 1 minus, yes? Yes or no?
No.
Let us do it. No. The answer is no. Okay, 99% yes, 1% no. What is that 1% no?
There should be minus sign.
And minus sign, because of the chain rule, yes? Because if I differentiate with this one, do it in your head. Y goes down, good, I have it here. And then this will be what? But is it finished? No,
minus
I have to
the
multiply by 1 minus x prime, which gives me
minus
a
one.
negative sign. So I should negative sign. Is that right? That is the engineering of it. But now, can you solve it? Do you remember? That was I'm saying. This was my obstacle. Why this was my obstacle? Because I already have it in mind how to do this one. This is geometric series. So I asked myself, how can I relate this to a geometric series that I can solve? Okay? So then what happens here? This becomes minus x d dx. And then do you know the answer? If you have forgotten the formula, let me write it here. How many of you remember? What is the sum of a geometric series? By the way, is geometric series always convergent? No, it is convergent only if
Yes.
the common ratio is between minus 1 and 1. Is it here? What is the common ratio here? If I put 1, it becomes what? 1 minus x, and the next one will be 1 minus x to power 2, 1 minus x to power 3, so every time I'm multiplying by 1 minus x. But is 1 minus x in the correct range of convergence? Yes, because x, what was it?
0.
It is 0. Okay, so everything is good. But the formula is 1 minus q, the common ratio I think is written by r, and then the first term. Okay, so what happens here? This becomes d dx. This becomes 1 minus common ratio, I told you, what is it? This. And then you put the first term on top. What is the first term? 1 minus? Is that right or not? Yes, please.
I did not understand what happened to the y term in the.
That is exactly the engineering of it. Okay, let me ask you again. Do you agree this one
Oh, I see.
is equal to this? That was the whole point, yes? But this is extremely simple now, yes? I have a minus x here, I have d dx, and then I have 1 minus x divided by x. I don't know, you just differentiate. For me, it's better to separate them, because I have something in my memory I want to use them. So this is 1 over x minus 1. 1 over x minus x over x, and I differentiate. What is the derivative of this guy? Minus 1 over x squared. The derivative of this one is 0, so you have your... Yes? Be ready, okay? There will be a harder engineering coming on now. So yeah, you have, this is the way. This is one thing you learn, put it in your toolbox and enjoy, you know, especially in the weekend, you can just do these problems, yes? So, this is very good. But what was my goal in calculating this, do you remember? I have to go backward and put it here, so I hope that you are not confused. Let me put the star here. And then this is a simple one. So from star, what can I conclude? E of y is equal to the integral from 0 to 1. The first question mark is answered now. Multiplied by 2x squared. Am I right? Yes. And then the x. But this is also so simple. This one and that one are gone, so it becomes 3 over 2x squared. And then from 0 to 1 is 3 over 2. Yes, the answer, at least this one, is correct. Are you comfortable now? Everything is okay? This is a very good exercise to review things.
Just 1 second.
Yes.
Last step.
What?
It's
This x
3x
and this
squared.
x are gone, so it becomes 3x, and
Yeah,
x
that
becomes
is-
x squared over 2. And there's a 3. These are simple things, yes? As soon as I see the answer is correct, so it means I have done it correctly. Yes? Because if I want to explain every detail, then I am stressed. Do you want to stay here for lunch again?
Yeah.
So let us actually continue. But of course I will be ready to answer after the lesson. Okay, but now we want to go to the variance. So you know what to do with the variance. What should I do?
Split it up into the two.
Variance of y, yes. This is the standard calculation of variance. Okay, so I don't have any problems here because I've already calculated this one. I want to calculate this. Again, in principle, you have to know how to repeat things. So what should I do? Do you remember what I did for EY? The same trick will work by unconscious and statistical. Yes, so you see I have to go here, and you adapt it for me in the new situation. So what should I write? Help me. Integral from where to where? Are you helping me? So help me.
0, 1.
So what? 0, 1. I don't see any help actually. So and then E on what should I write there?
Y when x is equal to y squared.
Yes, y squared. And then agree? Again, what is my problem? My problem is this one. Are you ready for new engineering? So E y squared. Anyone, please help me to write at least the starting point. Don't look at the formulas, please. Okay? Because you have to have these formulas in mind, you know? So what should I do? This is something you have to, of course, this is very intuitive. And then you have to remember it, that's the definition. So what should I write here? First of all, do you think it will be a sigma or an integral? These are the important questions. Why? Why sigma? Because this one, you have expectation of y squared, and y squared is discrete. So it becomes sigma. X is already chosen, remember that. So can you tell me what should I write here? Unconscious statistician? Y squared. And then P. Some common mistake is people want to put y squared here. No, that is the meaning of unconscious statistician. Yes? This one will change only. So, and then y goes from 1 to infinity. And then what do I do? Okay. This one is y squared. I copy and paste that, you know. Can you see what's happening? I put x out. Yes. Do you remember? There is no pointer here. Okay, so you see, this one that is my problem now is very similar to what I had before. The difference is what? There is a square. Okay, but if you are a good engineer in mathematics, what do you think first? Very good, very good. Now these questions are actually very simple, but I mean, it is, if you don't have any idea, what do you want to do? Some people try to manipulate things without having a strategy. Sometimes, if you're so lucky, it works. And if you're so lucky, it is better to buy a lotto, and then you don't need to study anymore. Okay? So, this means that we are not usually that lucky that start manipulating the formulas without any goal in mind. But now, when you set second derivative, it opens a strategy in front of you. And then you have to give energy to this strategy, yes? Energy engineering is assets, yes, investment, things like that. But then, of course, might be the idea is not working. And by the way, it's very hard in research. If you have a novel idea and then you push yourself onto it and you don't want to believe, no, it's not working. So that's a very, very delicate balance, what to do, yes? So, how can I actually continue? So can you engineer it now? The idea is clear, second derivative. Do it. Sum y goes from 1 to infinity. So I was also careless in my calculations because I was so excited I just continued. But what should I write here now?
Y.
Y. But do I know this?
Why
To the power of y. So now might be we have to do something. That's not exactly that. Yes.
Yeah, the chain rules.
And then there is a minus sign as well because of that idea of the chain. Yes? So first of all, let us see what we have. If I differentiate this, first of all, is this equality legal? Y goes down, it becomes y squared, 1 minus x to power 1 minus 1, and then multiplied by an extra minus sign. This minus sign compensates that one. So at least this is correct. Okay, no, I think we have to do some tricks again. But now I thought that this will be that one, but unfortunately that is not that one, is it? I have to do one more engineering. Okay, can we do that now?
If we try to find another primitive, we have to divide
Okay, but do it.
y plus 1. It's going to be very messy.
No, it is not messy. I mean, it might be messy. It depends because the difference between you and me is that sometimes I don't say those are messy because I love calculations. Yes. If you don't like it, then
Can't we break out 1 minus x on the sum, and then we have?
yes, very good. That's the idea. Simple as that. If you know what you are looking for, that's my message to you. If you know what you are looking for, you will find a way. So what is the obstacle? That I cannot do more or less the same engineering once more? Yeah, because this one and that one are the same. I need them, they differ by 1. So what do you do here now? Can you tell me? So I put minus x, d dx, and what was your suggestion?
So outside of the sum, but within the differential, I want 1 minus x.
Very good. So let me do it in 2 steps. Might be they will be confused. Let me do it in 2 steps. What she's suggesting very nicely, because she knows what she's looking for now, she's doing it like this. Everyone agrees? You see, I kept this one. What I am claiming is that this guy can be written in this form. Do you agree with me? Yes, I just put 1 factor of 1 minus x out. But be careful. Can I flip it out? No, because this is differentiation with respect to x, and that is x. I cannot pull it out. Minus sign I could pull out, but this one no. But now, can you use the trick again? So this becomes minus x d dx. What happens? 1 minus x. But I need one more engineering, and you are actually very good engineer now. So what should I do? Help me, help me. d dx, very good, so you're learning. Sigma, y goes from 1 to infinity.
1 minus x to the y power.
Y power. Then need one adjustment again.
I have changed, so minus sign.
This becomes positive. Okay, let us double check. So you see, this one, I copied and pasted in disguised form by pulling 1 minus x out. But this one, copy, paste, copy, paste, copy, paste, and this one, if I do it, it gives me this. Are you okay? Everything is okay. But then exactly because of that chain rule, I need 1 minus sign comes out and it becomes positive. But now tell me, is this a hard problem for you? No, that's a geometric series, yes? But you have to be a little bit careful about differentiations. So it becomes plus x d dx, and 1 minus x, and then this one is d dx, and then this one, can you do it in your head? We do it somewhere. What was it? Yes, up there. So it is 1, so let me write. It is 1 minus x, 1 minus 1 minus x. Okay? Understandable? Okay, but everything hopefully you understand is doable. So because this one just simply becomes x and I divide, so let me just write it here. X d dx, and then 1 minus, don't change the order and things like that. Be careful about when you're dealing with operators. Okay, so this becomes 1 over x minus 1. Yes? So then what happens? So just normal calculations. So this one, I have it in my memory, is 1 minus 1 over x squared. I multiply it here, I flip this, so it becomes x minus 1 x squared. These are simple things, okay? And I prefer to divide. Of course, you can use the quotient rule, but usually I don't like quotient rule. So x over this one is 1 over x, and then minus 1 over x squared. That's up to you. If you want, you can use it becomes 2x squared. I prefer to write the positive sign first. I'm optimistic. And then it becomes minus 1 over x. So then, finish. So this one is done. You have to go back and put it here. Okay, so ey squared. So let me give a, I don't know, 3 squared or something. Okay, so then 3 star allows me to conclude what? Ey squared is equal to this one is this guy, integral from 0 to 1, and then I have 2 over x squared minus 1 over x multiplied by f sub x, which was 3x squared equals. Oh, I'm confused. I don't know which problem is that, by the way. No, this is here.
Oh, no.
Yes, that's here. So, and then I multiply it by that. So what happens? It becomes integral from 0 to 1. I multiply, it becomes 6 minus 3x dx. Am I missing something or not? Am I right? So 6 minus 3 halves is 9 over 2. Yes? Okay. So this is my ey squared. Then the final question, do you remember? The variance of y is ey squared minus ey totally squared. So what is ey squared? Just calculated 9 over 2. What was ey? Do you remember? 3 over 2 squared 9 over 4. 9 over 2 minus 9 over 4 is, this is half of this, so 9 over 4 again. Yes? Yes? Is the answer correct? Yes. Okay. I will not be able to finish the next one unless we want to stay. Okay. And I wanted to also solve the exam question from 2007. These are good problems, but then I don't know what to do. Do you want me to continue or not?
Continue.
Yes, we can do as before, yes? Because I actually wanted to request that instead of having office hour, I want to have one classroom book so that I can come and solve more problems. And then if you are, but I don't know if you are okay to join extra lessons or not. Is it good? But the only problem is that because office hours, I really don't like them. So sit down on most of them. But if I remember, what was that? It was the expectation value of the product minus the product of expectations. So here we don't have any problems. What was that? E of x was, we didn't calculate E of x? I remember? No, we didn't calculate. We have to calculate. So we have this one is already done. It is 3/2. This one I should calculate. This one I should calculate. I think this is very simple. Yes, because this is the standard, the most standard problem. So what should I write for the integral? Integral from 0 to 1 x f of x dx x3. So that one is done. But how do you think we should do this one? Yes, if you are not comfortable, you can of course leave. So I am offending you by keeping you here. And that is why I'm crazy, but you can just leave. Yes, that's the problem. If you want, I think that will be a hard time, because usually if you want to calculate this, how should you calculate this? My first thought. That is also my first thought. Then and that was my problem. So if I want to calculate this, usually the first thing comes to my mind is a double integral of x times y, but yes, but at least I put minus infinity for both. This is usually that these are hard problems, because usually what you have as standard in your brain, when you want to calculate this, the first thing comes to mind is this. Okay? But this is not very good here. So either you have to find a way to force this to work, which might work, or you have to change your strategy. So you see, I have a strategy to start with. This is my standard strategy to tackle this problem. And I realized that, okay, how can I go forward? Because I hope that you are not forgetting things. I don't have access to this. If this is possible, I have to calculate this myself first. And that's a little bit problem. You know why? Why usually, in principle, I want to give up? Because I need to prove reason to give up. So what is that reason to give up for this? What? No, yeah, one of them is discrete and the other one is continuous. So at least this is a good idea. So you see, when I want to sit down and solve the problem, first I think about this, and I would say, no, it is not working because one of them is discrete, one of them is continuous, and this formula is for the case that both of them are continuous. So, I mean, I have to find a way. But now you learned something today, and probably these exercises are all designed for that. I don't know which one I should do. So I should move that over here. So what is your next step? If this cannot happen, you have a little bit of hard time, what do you think I will do? What do you want to do? You haven't, I just want you to feel how we can write this. So E x, y, I want to use the conditioning probability. You remember we start from that thing as well. Today's lesson, do you remember I started with this and I conditioned on probability. So what should I do here? Sum over all integrals, yes, of xy, if x is x, yes. You know why do I put integral, not sum? These are very important questions. Please write some notes, you know. Because in principle I can start with a sigma, I can start with an integral. Why did I choose to start with an integral? Because I am conditioning over x. And x is it continuous?
Yes.
Yes, x is continuous. So I have to write what here? Oh, sorry. Yeah, that big capital P was correct, but I should write it like this if I want to. Yes? these are very important questions. You might get confused if you don't learn it completely. So why should I start with sigma? Because I'm integrating over this x. X is continuous. That is the total expectation value forward. Something, I don't know how many of you have read the book. There is one exercise in the middle of the book. Okay, I don't want, because there's no time. What do you think I can write here? This is one of the exercises, not in the exercise session. When you are reading the text, there is one exercise in the middle. There are the properties of conditional expectation value. But you really don't need the formula. Ask Lucas, are you allowed to use those during the exam, or you have to prove them? I will not prove them here. The proof is extremely simple. But rely on your intuition. You know that I did my PhD in mathematical physics, and I was mainly in physics department. They could only feel things. I don't know how. I feel this, I feel that. I was crazy there. Okay? But now here is good, because you can feel what does it mean. Just read it. Expectation value of the product of these two things if I know x is equal to x. So physicist method. So what is it? It means that what is this capital X indeed? Is a small x. Yes. And then what happens, because, so let me do that. This is feeling, but there is a proof for it. Okay? So I would write it as little x, capital Y, x equals to x. And then f of x, x dx. But I can go one step forward. There is also another property in the same exercise in the Alan Good book. This is a very nice note. No, you know Alan Good? The Nobel physicist, Nobel laureate physicist. Nice inflation theory. But the spelling is a little bit different. You know? Alan, the physicist, is this guy. Okay? So there's an H. So there is one H between Nobel Prize winner and not Nobel Prize winner. So then what happens here? What can I do with this little x? This little x is not a random variable. What is it now? It's a number. I can pull it out in the same exercise. But these are very simple things, you know. So integral from 0 to 1, x goes out, and then if you want, you can eat your lunch now. Okay. But did I calculate this? Do you remember something about that? It's up there. What was the answer? Is this the same problem or not?
Yes.
Yes, it is the same problem. It's 1 over x. Yes? So please be careful. You need to motivate yourself. I put a star here. Motivate yourself. Okay, so, and then this becomes integral from 0 to 1, x, 1 over x, times 3x squared, dx. The answer is 1. X and x are gone. X cubed divided by 3 is x cubed. Running from 0 to 1 is 1. Okay, so I have my e, x, and y. Oh, I think I did something. No. Yes, I calculate this one. This is 3 over 4. So let me, I ran out from stars, so let me do box. Conclude that the covariance of x and y is equal to this one was 1, and then minus that one is 3/4 multiplied by 3/2. 1 minus 9 over 8, which is minus 1 over. Okay, that's correct. One more thing, and at least we can solve this problem completely. And let us see what we can do. There are very interesting problems. This guy who has written this book, he knew a lot actually. So first I didn't like the book, but when now I understand, because he wants to write everything he knows in the lecture notes, and then he has to sacrifice the precision.
Just a quick question. Where did that 1 over x come from?
The 1 over, so this is the question mark. That is the same problem I calculated up there. Yes. So for me it is very random, but when you are writing it, you can see it. You know, you can keep track of it. So, what should I do next? I have to calculate, according to the problem, one more step, this one. So this is done, this is done, this is done, this is the one left. Okay. So what should I do? What type of random variable is this? Discrete. So what do you think I will write in front? Sigma, sigma of what? I don't know if you want to write sigma or not. I want to wait for you because this is crucial. You need to know where to start with. There is no sigma here. Yes?
No.
So what is this one then? There is a definition, yes?
I was going to suggest the total probability using
Very good, very good. Yes? Because this means what? This means capital P of y is equal to y. And whenever calculating a probability is hard, you learn a very generic tool is that, okay, condition, put condition on it. But condition on what? So on which I want to put condition on?
Y condition that x equals
P, the probability of y equals to y if
x equal to x.
x equal to x
Times
multiplied by the probability of x equal to x. Okay, but integral or sum?
integral
Because
the other one.
you are putting condition on this continuous variable. So integral and then dx. But of course, if you know that your random variable is continuous, what is the name of this? What is another notation for this? F x x. Yes? So this we know. So it shows already that what you have to do is to put 0 to 1. And this one you already know it is what? 3x squared. But what can I do with that one? I want the probability that y is y if x is x.
definition of
Okay, so just think a little bit about that. How is it possible to calculate that part in this problem? Yes, that's a little bit strange because in principle this should be simpler, but we get used to it and then we forget about things. Yes, but now that's what I'm saying. What is this guy? It's on the board, but it is in disguise form. What is the meaning of this?
It's given in the yellow on the.
Ah, no, not joint. Because it is conditional. Joint is comma. Yeah. No. Yes. What should I? What notation I want to write for it? That's what I mean.
conditional.
Yes. P. Y. When x is x of. Do you agree? So it was nothing. You yourself told me write conditional probability, but you might be confused about the notations you are using. Okay? For me, writing this first is easier because in elementary courses we learn this notation and then we go higher, we change the notation. So I always start from what I know very good and then I ask myself, what is the meaning of this symbol? This is. What's the meaning of this symbol? This is. Because you don't need to look for it. Everything is on the board, is it? Yes. Do you remember? Yes. You engineered a lot with this today. But now the last step. So the last step is this. 0 to 1. Let me write, I think it is negative. 0 to 1. Help me. What is that? Yes. Yes. And then multiplied by 3x squared, and then dx. Yes? So, what should I do? I would simplify this a little bit. But is it your moment of relief now? For me, it was, because I immediately know what to do with this integral. Okay? Can you tell me what to do if I insist to calculate? Okay, if that is the case, you have to defend yourself and work it out. It might work. But what is the most important technique? You know, there should be a reason to change the strategy. This way of learning mathematics is important. You should have some anchors in your brain about how to do things. And if you want to deviate from those anchors, you have to have a good reason. So which method you learned first in university for integration? Name it. What was the name? Names are extremely important.
Substitution.
Yes, very good. So that was, so if I want to go to integration by parts, which might work, I have to have a good reason to deviate from the simplest possible case. Okay? But I know that the method of substitution worked for this very good. Okay? One thing that comes to mind, can I use binomial theorem here? Yes or no? You know what is the binomial, Newton's binomial theorem, yes? Yes? Can I use binomial theorem here to solve this integral?
Why is this?
No, why is the natural number of it? No, of course I can raise it to power because this one is natural. But is it helpful to calculate this integral? In principle, yes. Because when I raise it to power 2, what is the name of generating thing I want name? You generate something. What is the name of that thing in mathematics? If I raise this to power n, the first one to power something multiplied this, and then it becomes something. What is the name of that thing? You see how much it is important to know the names. Polynomial. Okay? So it's the polynomial, and then that polynomial is multiplied by x cubed, becomes a new polynomial. So in the worst case scenario, this is something that you can do. But it is not efficient. Okay? About the integration by parts, if you know what to do, that's also okay. I think it works here. But the method of substitution, can you tell me what should I choose? I want to introduce a new variable, t. Don't look for something strange. You know, let me guide you. What was my problem? Do you like Newton's method to do that? No. It was possible in principle, not efficient. Especially in the exam, don't go for brute force. Because you lose time, you become stressed, and then you cannot think properly. Okay? So, in principle it works. But what was the problem? Which one do you prefer? These are the questions I ask myself. Do you prefer this integral to calculate in the exam? Yes, this one. Do you prefer to calculate this integral in the exam? Or do you prefer to y minus 1 here? Or do you prefer this integral in the exam? That one. Why? Because raising it to power 3, the same idea, but I raise it to power 3. And it will be 4 terms. But if I raise this to power 1 minus y, it will be y terms. Which one you prefer? 3 terms. Yes, or 4 terms, yes, 4 terms. Okay, but this is the idea. You see, this is, in mathematics you should like, love, dislike, things like that. It is doable, but I dislike it, so I have to get rid of it. Yes? I don't know, if you don't like your girlfriend, probably you find a way to get rid of it. Yes, something like that, or the other way around. So this means that if I don't like it, I have to learn how to get rid of it. Can you tell me with which substitution I can? You see, when I guide you, okay, so when I guide you, you know the answer. But the problem is that you have to guide yourself. Okay? These are the things, you know. But there is one prerequisite for these things, and that is love. Yes, you have to love, otherwise you do not sacrifice. Sacrifice time. Yes? Yes? Okay. And then if you are a master, that is my pre-assumption about you. You love your subject. If you don't like your subject, by the way, why you are studying? Because the person who loves the subject will win the competition. No company will give you the job. They don't care about you. They just care about your problem-solving skills. And if you don't love the subject, another person just loves the subject, of course you will lose. And it means that you wasted your time. As simple as that. So we are blaming China. Of course, the people there are working 18 hours a day. Yes. But that is as simple as that. And that is awful that we are left behind. So we have to have some nationalism here. We have to fight. Yes. Don't take these things for granted, because if you are, I have lived in this country, Iran, so I can see that many values in Sweden, you don't feel it. You wake it up, you take it for granted, and then you say, okay, this is the life. No, this is not the life. Yeah, this is life in Sweden, and it is becoming a little bit worse now. You know why? Because we don't work. We don't work. And we do not love. And the reason that we don't work is because we don't love our job. This is a very bad thing happening in Western countries. I mean, everywhere more or less, because Western culture is dominated. But the problem is that if you don't like the job, so what is the point? You cannot work. Especially these days, you are unlucky. I mean, the engineers generate. I think all these problems can be solved by ChatGPT 5. So, sooner or later, everything will change its meaning. Yes. So, what is the point that I will be here teaching you if you can just type something and the ChatGPT can teach you? By the way, Gemini, you know that it can see your screen. So I can start solving the problem, and Gemini looking me. Okay, don't do that, do this, do that, do that. Exactly like a teacher, so it could be obsolete. The only reason that we are here is because just human interaction. Probably, yes? Yeah, start training loving heart. You know, you have to have a loving heart for what you are doing, otherwise, yeah, it's very hard. Your generation, sorry, it will be screwed up if you don't love, you know, what you want to do then. Yeah, it's a very hard time. So, yeah, be good mathematicians. And this guy, Terence Tao, is actually elevating this to a higher level. So it means that you just give your conjecture to the machine, and the machine gives you a proof for it. Okay, so it's horrible. Okay, so I don't know what to love then. That's the problem. You know what happens? It becomes like alpha zero. Have you heard about alpha zero? Probably. No one. This is the chess player, designed by Google Deep. Okay, so no human being even think to compete with it. It is finished. No human can beat alpha zero. Okay, but still we are playing chess. So might be in the future we still do mathematics, even though AI knows everything. Yes. Okay, but now let us go here. This becomes what? 1 minus x. You see, is this an aha moment for you, a relief moment? If not, you haven't done, let me be a little bit rude, you know, you haven't done your job before very good. This should be a moment of relief for you if I tell you what to do. But because if I know this is the substitution, I know exactly algorithmically what to do, so you have to be also like that. So what should I do next?
You have to substitute D into
I differentiate, yes, and then I change the new limits. I would say that the old variable goes from 0 to 1, then t goes from, if x is 0, t is 1, if x is 1, t is 0. So then this means that this becomes 3 times integral from 1 to 0, be careful, and then instead of x, this one I can write what? I can write t to the power of 1 minus 1. Instead of dx, I have to write what? Minus dt. And then instead of x, I can write 1 minus t to the power of 3. Yes or no? Okay? And then I use this minus sign to do what? To flip. Did I reach my goal? That is the exam question I love. I looked for it and found it, yes? So, but how can I calculate now? Are you ready? by 3 integral from 0 to 1, I raise it to power 3. It's easy. The first one to power 3 minus 3 times the first one plus the other way around, and then minus 3 cubed, and then multiplied by t to power 1 minus 1 dt. Yes? And then what do? I multiply. So this becomes t to the power 1 minus y minus 3t to the power of y plus 3t to the power of y plus 1 minus t to the power of y plus 2 and dt. Yes? I hope that this is an extremely simple problem, yes? So this becomes 3. This one becomes what? T to the power of y divided by 1. Everyone understands that? Yes? I hope that you are not confused. Don't think that y is just a number. Yes? So it is t to the power of 1 unit more divided by, this is the primitive function for this. Primitive function for this. Primitive function for that. Primitive function for that. And then I have to run it from what? 0 to 1. I love always 0 because it will be 0. I also love 1 because 1 doesn't have any problems. So this becomes 1 over y minus 3 over y plus 1 plus 3 over y plus 2 and then minus 1 over y plus 3, and that's it. But because I want to check my answer, this is not the answer given, so I have to manipulate it a little bit. So how can I manipulate it? Easy. Because if you want to take the common denominator as this answer is motivating you, you will take 4 of them, and then what will be the problem? In the numerator of each one, you will have three things to multiply. Okay? It is doable if you want to do that, but I prefer not to do it. Okay? There is a symmetry going on, do you see? It's always a hint. These are the things that you have to be good at. What is the symmetry? There is a 3 here, there is a 3 here. It is crying out, take us together. And these were also symmetry. Okay? So I will do the same thing. But can you do it in your head? Between this one and this one, what is the common denominator? It's y plus 3. Y plus 3 goes here. Remember it in your head. Y goes here with negative sign. What is left? Yes? And between these two, I factor a minus 3 out. This is positive, this is negative now. But the common denominator is y plus 1, y plus 2. And then compare it with this one. This y plus 2 goes up there. Be careful, it's positive. But this y plus 1 goes there with negative because I took the negative one out. What is left? Do you see what I'm doing? I'm calculating this. So can you do it in your head? The common denominator is here. Minus 3 is copied and pasted. This one is here. What is the numerator? Do it in your head. Okay? If you see the answer, I was very happy to see the answer because there is so at least I can factor a 3 out. I have a factor of 9. And then one more. Okay, because I want to combine. So if I factor a 3 out, what is up there? It is 1. What is up there? It is 1. And now I take the common denominator. Y plus 1, y plus 2, y plus 3. Okay, compare it with this one. What is extra? What is extra? Y plus 1 and y plus 2 are extra. Do you agree? So it goes up there. So it becomes like this. Minus, remember I factored the 3 out from both of them. This is why it is 9. Okay, and then this will go there. Yes? Okay, can you do it in your head now? Y squared minus y squared, gone. 3y minus y, 2y. Remember that. So did I make a mistake?
Yeah, y plus 3.
What? I've made a mistake probably. So let me compare this one with this one. Y and y plus 3 are gone. So what is left? y plus 1, and that is correct.
Yeah.
This one is that, yes?
Minus
What is that? It is 3.
plus two.
Yes, thank you. So y squared gone, 3y gone, 2 minus 2. And 2 times 9 is 18. So from the compulsory ones, one is left. And that's a good problem, that's an exam problem. I will probably make it next time, okay? I don't know how much we have to do next time. But I would really recommend you to do the next problem. It's a good problem. Yes, but try to memorize everything you need to memorize and then start doing the problem, okay? Which problem